Welcome to Brain Vision.
Okay, so for this question, we can apply the energy balance equation, which is E dot in is equal to E dot out. If we expand it, we have Q dot plus M dot H1 is equal to M dot H2. So Q dot here is the heat transfer rates for the oil, okay? And M dot here is the mass flow rate of the oil. H1 is the inlet enthalpy of the oil, and H2 here is the exit enthalpy for the oil. So if you do some arrangement here, we have Q dot is equal to M dot times H2 minus H1, which is equal to M dot times Cp times T2 minus T1. Cp is the specific heat for the oil, and T2 is the exit temperature for the oil, which is the final temperature for the oil. And T1 is the initial temperature for the oil, which is the inlet temperature for the oil. And then we know that the mass flow rate is given as 2 kilograms per second, and the specific heat for the oil is 2.2 kilojoule per kilogram times degrees Celsius. We know T2 is 40 degrees Celsius and T1 is 150 degrees Celsius. So now let's plug in back to the equation to determine the rate of heat transfer in the oil, which is equal to 2 kilograms per second multiplied by 2.20 kilojoule per kilogram times degrees Celsius, and then times 40 degrees Celsius minus 150 degrees Celsius, and this will give us the rate of heat transfer in the oil is about negative 484 kilowatts, which means that the oil is losing heat at 484 kilojoule per second. Okay, so if the oil is losing heat, that means the water is getting the same amount of heat, which is 484 kilowatts. Okay, with the sign is positive. So therefore, we can determine the exit temperature for the water. So first, we need to set our equation here, which is Q dot W plus M dot W times HW1 is equal to M dot W times HW2. So Q dot W here is the rate of heat transfer for the water, and M dot W is the mass flow rate for the water. HW1 here is the initial enthalpy for the water, and HW2 here is the final enthalpy for the water. So if we do some arrangement here, eventually we have Q dot W is equal to M dot W times CPW, and then times TW2 minus TW1. And then we'll have TW2 is equal to TW1 plus Q dot W over M dot W times CPW. So TW2 here is the exit temperature of water we need to determine. And TW1 here is the inlet temperature for the water. And we know Q dot W is the rate of heat transfer for the water, and M dot W is the mass flow rate. CPW is the specific heat for the water. So we know TW1 is given as 22 degrees Celsius. Q dot W is 484 kilowatts. M dot W is 1.5 kilogram per second, and the CPW is 4.18 kilojoule per kilogram times degrees Celsius. So now let's plug in back to the equation to determine the exit temperature of the water, which is equal to 22 degrees Celsius plus 484 kilowatts over 1.5 kilogram per second, and then multiply by 4.18 kilojoule per kilogram times degrees Celsius. And this will give us the exit temperature for the water is about 99.19 degrees Celsius. And these are the answers for this question.